And we are at our last problem for our exam 3 practice questions. So let's look at basically our equation 66 once again. So I'm looking at the following mechanics scenario. Polymeric material, what I need to know. Young's modulus is equal to 1 GPa. My Poisson's ratio is equal to 0.4. Applying the force of 500 kilopascals, cubic mold made of rigid walls. And that's pretty much it. So I need to go and actually start to apply to force. It's not really a force. This is a stress. So be correct, Professor Steinman. But anyways, so we can now, so I'm given the stress in the 3-3. So that's equal to, 3-3, we know this value. So if I look at the stress and strain tensors, these are all rigid walls. I'm going to assume that they are basically lubricated. Is there going to be a strain in the 3-3? Absolutely. We don't know what it is. Is there going to be a strain in the 2-2? No. 1-1? No, because they're rigid. There will be a stress in the 1-1. There will be a stress in the 2-2. I don't know this. I don't know this. I don't know this. 3 equations, 3 unknowns. We know how to attack this problem now. So I'm going to say that my y is equal to 1 times 10 to the 9. Nu is equal to 0.4. My sigma 1 is unknown, but I know actually my E11 is equal to 0, E22 equals 0, and sig 33 is equal to, in this problem, 500 kilopascals, so 500 times 10 to the 3, and there we go, and now I'm going to solve. E11 set equal to 1 divided by y times, basically, sigma 1 minus nu times sig 22 plus sig 33, and there we go, and then I'm going to do E22, set that equal to 1 divided by y times sig 22 minus nu times sig 33 plus sig 11, and then finally E33, set that equal to 1 over y times sig 33 minus nu times sig 11 plus sig 22. And we'll close that up. I'm going to do sig 11, sig 22, and then sig 22, and E33. Let's see what we get. And let's look at these values. So 3-3. Ooh, see my mistake here? Always, is this positive or negative? That should be in compression. Let's solve again. So now, sigma 1, again, my material wants to bounce out, but it's constrained here. My strain here is in the negative direction, so I've got my values. So I'm going to go ahead, actually, let's go ahead and plug this in. So this equals to this. Stress the same, because we're a cubic linear elastic isotropic material, and then the strain is equal to this. Fantastic. So I've got my values here, and now I can go and start to, basically I see that I have a matrix that is in my principal stress state, and now I can start to kind of solve the rest of these values. If the walls were not lubricated, how the stress and the strain tensors change? Well, if it's not lubricated, as I push down here, I could have a shear that looks like this. So that shear would be, again, in the normal 1 direction, pointing to the 3, so I'd have a sigma 1,3 equals sigma 3,1. As I push down, I could also have a shear in this direction, so that's a sigma 2,3 equals sigma 3,2. What other shears can basically exist? I think those are the primary ones. Maybe 1, 2. It kind of depends. I really honestly can't see a direction where that would be supernatural, not supernatural to show. So I think these would exist, and then hence epsilon 2,3 equals epsilon 3,2. Epsilon 1,3 is equal to epsilon 3,1. And you could write those equations out. Epsilon 1,3 is equal to 1 over E times 1 plus nu times sigma 1,3. So we can get those values. So tick, tick. Turns out the material will yield if the maximum shear exceeds the stress of the orange curve. So again, maximum shear stress of my orange curve down below. So again, let's see. Material will, if the maximum shear stress exceeds the yield stress of the orange curve. So the maximum shear stress will again be sigma 1,1. Well, actually, let's look at these values. So is sigma 1,1 greater than sigma 3,3? true. So sigma 11, basically sigma 1 minus sig 33 divided by 2. That is going to be my, so about 83 kilopascals. Again, these are megapascals, so nope, no yielding. And then it asks us, so nope, that's not true. True, I'll see if the yield strain, if the strain exceeds the yield strain of the blue curve. So yield strain of the blue curve is around about 5%. Let's see what my strain is. My strain is definitely less than that, so I'm not going to yield either. So no yielding. Which curve could have been in yield for the longest time? Well, it's going to be the one with the lowest yield stress, which is going to be my black curve. That's it. That is the last problem. So congrats. You made it through the entire course. Study hard for the last exam, and then I will see you all in future classes. Thank you. It's been a pleasure. Thanks. Bye.